Ravnad. Today I explain you a simple concept of 10th class, that is set theory. Set theory was first introduced by German mathematician George Cantor, and the basic concept of set theory is a set. What is set? Set is a collection of well defined objects. Here well defined means universally known. That means the object should be recognized by each and everyone. For example, I am giving you two statements here. One is some natural numbers and other one is natural numbers less than 5. These are two collections here. If I ask you say some natural numbers, what is your answer? You may give the answer as set of 1 2, and some maybe give the answer as set of 1 2 3 4. Is it 2 or 3 or 1 or more or none? Can you say? No, you can't. Because there is no particular number attached to the word sum. So you can give the number of elements in the set as 1, or you can give the number of elements in the set as 2 or 3 or more, or none also. So that's why here it clearly indicates that the elements or the objects in this collection are not well defined. So such type of statements or such type of collections are not sets. If we take the second one, natural numbers less than 5. So if you have a basic knowledge, basic mathematical knowledge, simply you give the answer as set of 1 2 3 4, isn't it? Because all natural numbers less than 5 are 1 2 3 4. Set of natural numbers begins with 1. So after that limitation is there, you have to say the natural numbers less than 5. Everybody gives the same answer here. So that's why natural numbers less than 5 can be listed equally by all persons. So here the objects are well defined. So this collection is said to be a set. And one more thing to be remembered by you, that is, if any adjective is involved in this collection, for example, clever boys in your class. So how can you define a clever boy? Is it according to the academic performance or other else? So you can't define the cleverness. There is no particular measure to estimate the cleverness of a boy, isn't it? So that's why if any adjective like bad, good, clever, beautiful, such adjectives are involved in the collection, simply you have to say that those collections are not sets. And if the word some is also added or some is also involved in that statement, simply say they are not sets. Is it clear? Next, generally sets are indicated with uppercase letters like A, B, C, D, etc. For example, I am writing here one set, A equals to set of 1, 2, 3, 4. So this set consists of 4 objects here, or 4 elements. Now the number of elements present in a set is called its cardinal number. Cardinal number of A, and it is represented with n of A. Sometimes it is also called as order of the set, and it is represented with O of A. In this particular examples, how many numbers are there or how many elements are there in A? 4 elements are there. So cardinal number of A is 4. So that's why you can write it as n of A equals to 4 or O of A equals to 4. And one more thing is, the usage of the symbol belongs to and does not belong to. Suppose if you take this set A equals to set of 1, 2, 3, 4, 4 elements are there. And what are those 4 elements here? 1, 2, 3, 4. 1 is present in A. So it can be represented mathematically as 1 belongs to A. And another element is 2. We can write as 2 belongs to A. 3 belongs to A. 4 belongs to A. If you take any other element which is not in A, for example, take 0. 0 is not present in A. So you can write 0 does not belong to A. So this is the usage of symbol belongs to and not belongs to. If a particular element is there in a given set, then you have to use the symbol belongs to. Use the symbol belongs to between element and the set. So 1 belongs to A, 2 belongs to A, like that, and 0 does not belong to A. So this is the usage of belongs to and does not belong to. And next topic is notation of a set. How can you describe a set? So there are two ways to describe a set. One is roster form. It is also called as list form or tabular form. The second way of representation is rule form or set builder form. In roster form, all the elements are listed, which are enclosed between flower brasses, and all the elements are separated by commas. This type of representation is called roster form. As all the elements are listed, this form is also known as list form. And the second way of representation of set is a rule form. Instead of writing all the elements, if we write their common property, in this representation, so you have to write set of x. What is x here? X is an arbitrary element, so which is nothing but a representative element. It represents each and every element of that given set. After x, you have to write a slant bar or colon and read them as such that, x such that. So immediately you have to write the characteristic of a common property of each and every element which are present in that set. Here I am writing x belongs to n. That means each and every element is a natural number. As natural numbers are infinite, we can't leave the character x belongs to n stage. And you have to write the range also. Here natural numbers are less than 5. So you have to indicate that x less than 5. So each and every element of that set follows two conditions. One is x belongs to n. That means each element is a natural number. And second condition is x less than 5. That means each natural number is less than 5. See this example. Take each and every element here. Take 1 and keep 1 in the place of x and read the rule form now. 1 such that 1 belongs to n and 1 less than 5. 1 is a natural number and 1 less than 5. Both conditions are satisfied. And in the same way, if you keep 2 or 3 or 4, all those 4 elements satisfied by these two conditions. Other than these 4, if you take any element, suppose take 0 and keep 0 in the place of x and read it now. 0 such that 0 belongs to n. Is it true? 0 is not a natural number. It is a whole number, right? So that's why the first condition is failed. So 0 is not fit for that condition. And if you take 5, read now. 5 such that 5 belongs to n. 5 is a natural number. 5 less than 5. 5 is a natural number. That first condition is satisfied. If you take 5 less than 5, is it true? No, because 5 is not less than itself. It is equal to itself. So the second condition is failed. So 5 does not belong to the given set. So in this way, If you write the exact common property or exact condition in that rule form, which is suitable for all the given elements, then this is approved for those all elements.